Hello, my name is Hakon and welcome back to my channel and a little video, another little tutorial on the Empress Effects Zoia, the modular patchable synthesizer in a little box where the only limitation is your imagination. Now, it has been a while since I did a tutorial now, but one of the more recent ones I did was a video where I demonstrated how you could make a sequencer that could go forwards, backwards, or random. Now, the method that I used in that particular patch was a little bit more complex than it needed to be. I will show a link to that video here if you are interested, because of course the algorithms, the process, the method, the thought process, the problem solving is still something that I think is relevant, because any way to create a patch on the Zoia is a study in how to solve other problems. But while I was working on that particular patch, I came up with a far easier way to do the same thing. And that's what I'm going to demonstrate in this little tutorial today. And I've done the most bare bones basic functionality of this patch now in this tutorial. I might do a more complicated version later. The idea is that you have a sequencer that you can go in and you can change the notes, but you can also reverse the direction of the sequencer, and you can also set it to play randomly from that set of notes. And the easiest way to accomplish all of this, and this is without any more complex features, like for instance waiting until the end of the sequence to change direction or changing the number of steps played, anything like that, is this method that I'm going to show you right here. Okay, so first of all, in this patch, I'm using a 6-step sequencer, and the beginning for all this is the note values. And in order for this to work, one needs to define the note values with a set of value modules. So I've got here a set of 6 value modules, which are in order for the standard direction of the sequencer. It is note number 1, 2, 3, 4, 5, and 6. And then, of course, you can have different ways of adjusting these on the fly when you are playing. For instance, you can do it manually here. You can go in and you can change the encoder, or you can have these mapped to a MIDI controller, for instance. It's a little bit dark here. I think I'll actually just put a little bit more light on. Okay. So we have the note definitions here. And then these notes are then patched into 2 sequencers and an in switch. The first sequencer here, I'll just show you now. I'll just move this to the previous page. Actually, I'll move both sequencers to this page now. The first note value here is patched into the first step of the first sequencer and the last step of the second sequencer. The second note is patched into the second step of the first sequencer and the second to last step of the second sequencer. And I'm thinking you can already see what I'm doing here. And the third one, and the fourth one, fifth, and sixth. As you can see, the note values are patched in opposite order in these 2 sequences. And that is the very simple trick to how this works. So as you swap between using the output of one sequencer or the other, you are in effect reversing the direction of the sequence that is being played. Of course, in this basic version, it doesn't start at the end of the sequence or anything like that, but the order of the notes is the way you define it, and the order of the notes are then being played in the opposite order when you reverse direction. Additionally, the note values are patched into an in switch here. And the way an in switch works is it has a certain number of input channels, in this case 6, 1 for each note value. And then it has a channel selector pad. And the value that is in this pad is the one that decides which single one of these channels is directed to the output. So only one of these channels can be directed to the output, which means only one of the note values you defined in the value modules are going to be at the output. And this is what we use for the random note value. So it takes and basically now picks one of these notes at random, and I'll show you how that randomness is done in a few seconds, and then it sends that to the output there. The next thing I'm going to show you now is that how it picks a random number. I might as well do that right away because it's right here. So I've got a random module here that is constantly running, and as you can see, it is generating new random values all the time. In order for this to be useful to us, we can't send this directly to the switch. It would be all over the place. Is to send that to as an input to a sample and hold module. The way a sample and hold works is it has an input, which very often is a value that can change dynamically. It has a trigger input and an output. When it receives a trigger, when it receives a control value with a rising value at the input, it will immediately, as the value goes up here, it will copy the value at that specific time from the input to the output, and it will stay at the output until the next time that the trigger detects a rising value. And since this is a step sequencer, we have something to keep the time and to move the sequences forward, and that is an LFO, which I have here, square wave LFO, which is gating the sequencers, but the output of this is also patched into the sample and hold. So for every step of the sequence, the normal ones going forward or backward, as it were, it also copies a random value into the sample and hold here, and that random value is then what selects the channel that selects one of these note values to be the randomly selected one for that step. And of course, the way that a channel selector works in a switch is it takes the whole value range of the Zoia from 0 to 1 and divides it equally between the number of channels. So in this case, you have 6 channels, and it takes the value range from 0 to 1, divides by 6, and when you have value 0 to 0.166666, it is channel 1 that is selected, and when it is 0.166667 to 0.33333, I suppose, then it is the second one that is selected, etc. That's not important right now because now we're just getting a random value between 0 and 1, so it will select any of these channels now randomly. Okay, so we have now 3 different note values all the time. We have the one from the in switch, we have the one from, oops, that's not what I'm supposed to do. We have the one from the sequencer 1 and sequencer 2, we can call them, I suppose. So we've got 3 sets of note values coming out of these output pads here. And then there has to be a way to switch between them to select which one is the active one at any time. And when I was playing, you saw I had a little row of 3 buttons here that are red when they're off and green when they're on. And these are what I call radio buttons. That is a set of linked buttons where only one can be active at the same time. I'm not going to go through how that is done in this video because I've done several tutorials on that before. I'm going to link to the most recent one and probably the best one up here, and that will explain in detail how that is done. Basically, what these 3 buttons do now is the first one selects the forward moving sequencer, the second selects the reverse moving sequencer, and the third one selects the random value generator, where the values aren't random. Actually, it just picks at random from the set of notes we want to play. and these control in a way that is described in the radio button tutorial another in switch. So we have here an in switch that each of these is 3 channels. So we have the first sequencer is sending its output note value to channel 1, the second one to channel 2, and the random sequencer to channel 3. And so these 3 are used to select channel 1, 2, and 3 on this in switch. Of course, they are doing that by their different connection strengths into the radio button routine. So basically the first one now will output a value to this switch, a value that is between 0 and 0.333. The second one will output a value to the channel selector that is between 0.333 and 0.666, and the last one will be between 0.6667 and 1. And then that means that these select the one and only of these 3 note sources that then is going to be output to something else. So that is the note output that we are currently selecting from our 3 note sources. So, and that is what is sent now to, for instance, an oscillator, which is what I've done here. I'm not going to go through too much what I've done here because this is very basic synthesizer stuff, but there's an oscillator that is, let's see, where is it now? That is the oscillator right there, the pink one. And the output of the oscillator goes into a VCA. The VCA is controlled by an ADSR envelope that is triggered by the same LFO that advances the sequencers or picks a random note from the set. And then the output of the VCA goes into a delay with mod. The output of the delay with mod goes into a plate reverb. Plate reverb goes into the audio output. So nothing fancy, just a pretty standard thing, and it's a triangle oscillator in case you wondered. That's what I usually use for my demonstrations. These 2 modules up here are part of the radio button routine. So yeah, and that is pretty much it. So that is the easiest way by far you can make a sequencer go forward, backward, or random in the most basic way. Now, if you want to make this a little bit more comprehensive as a performance sequencer, there are a few more things you may want to add. First of all, you may want to have a visual indication of which step is active, which isn't necessary, but it looks nice and it's convenient, so you can see which step is actually active. You would want to be able to select how many steps are going to be played. You may want the option of only changing the direction at the end of the full sequence. What else? And of course, anything else you can do to manipulate sequencers, such as slurs and ties, changing the rhythm, etc., etc. And of course, I have made several tutorials where I've talked about different ways to control how a sequencer advances, and of course any of those can really be used to also control this patch, because now you have, unlike my other tutorial where I describe a different way of doing this, that would be much harder, but in this one you can use any of those methods to control these sequences as well. Right, so I think that's all I wanted to show you today. Quite a basic thing, quite a bare bones version of this particular principle. So quite easy, really. Instead of trying to figure out how to move a sequencer around, we are basically just using 3 different sequencers in a way, although one of them is a switch and 2 of them are sequencers, and we just patch the note values into different places instead of changing them in the sequence module itself. So I hope you found that useful. Whether you found the actual actual patch itself useful as something you can use in your own patches, or whether you found the method of solving a problem useful. Both very important things, I think, when it comes to the Zoia, because whatever you do on the Zoia, I think there's always an application for something else you may want to do on the Zoia. So anything you get exposed to as a way, a method, an algorithm, a way of approaching a problem is something that can be useful for something entirely different. Or it may also just inspire your way of thinking about what you can do on the Zoia to make you do something else as well. So it's all good, I think. Anyway, I hope you enjoyed that, and if you did, please like, share, comment, subscribe, join me on Patreon, buy me a coffee, all those things that you do, and I'll see you in my next one. Thank you. Bye-bye.